Okay, everybody, welcome back to Differential Equations, and today is another great day because we will be solving non-homogeneous first-order differential equations. So, I will just get right to it. I'll just show you the formula, explain to you why it works, and we will get to solving some problems. Whoa, what is this? What the hell? Oh, I'm on pen. Whoops. Alright, anyways, so we've already defined the non-homogeneous function, differential equation, rather. That would be in the previous video. I'd recommend you guys take a look if you haven't. Now, it will be in this form. So, we must do something where we create an integrating factor. Now, if you watched the previous video and you saw the solutions to homogeneous differential equations, you would recognize that this is pretty much the exact same thing, except this time there is no negative sign. Similar to previous solution, but no negative sign this time, behind the integral. So remember this. Essentially, what we will be doing is we will multiply each side of the equation by this integrating factor. So then we get y multiplied by this is equal to f of t times this, where f of t's are a function purely in t. But you can see here, it's taking the derivative of this chunk. Why is that? Well, it's all about the product rule. Now, I'm not really going to tell you too much of the theory behind this, because I'm just here to show you how to solve these. But essentially it has to do with the product rule, where the derivative of y multiplied by this integrating factor becomes dy dt plus y multiplied by p of t, all multiplied by that integrating factor. So we could just collapse it into this form. And you'll notice why this is important very shortly, my friend. The first thing you do is you get your integrating factor, e to the power of your function in terms of t, which is multiplied by y, this guy. Next, you need to, it will actually goes into this form. So the derivative with respect to your independent variable of y multiplied by your integrating factor is equal to f of t multiplied by your integrating factor. Do not forget to multiply this on both sides. Now, something we will be doing here is instead of taking the derivative of this and letting it all spill out, you can see that y is actually in a beautiful spot right now. So instead of taking the derivative, we're going to integrate both sides. Boom! So all we have to do next is divide by this integrating factor. And we solve for y. Isn't that awesome? Because it is. Okay, I recommend you guys give this a little bit of a rewind if you don't get it yet. But don't worry. Before you do that, I'm going to do some examples. First one I'll do with you guys. Shouldn't be that bad, but if you have any problems, holy shit, guys, we got ambushed by the math demons. Oh my god! We need to solve this one. Okay, we have to apply what we know to banish the rate of y back into... Okay, guys, we have to use what we know to solve this problem, and we have to do it quickly, because most of you will be doing this in an exam where you have not that much time. So get ready. Ready to rock? Let's rock out. So first things first, we need to recognize, well, what are we multiplying y by? It's 1 over t plus 2. Boom! Take the integral of that. Quite luckily, it is a natural log. And what do we know? The e and the natural log, they cancel out, baby. Boom! I didn't cancel it out yet. But don't worry, we have to multiply each side by this. So now we have the derivative with respect to time of this chunk, y multiplied by our integrating factor, is equal to f of t, or pure function of t, multiplied by this integrating factor. Boom! Okay, integrate each side. And before I do that, I hope I simplified the e to the power of the natural log, because that would make things so much easier. Absolutely I did. Wonderful. So you guys can easily just solve this yourselves. What is this? Just easy antiderivatives on the right. Boom, baby. Don't forget your constant of integration. And, well, quite simply, you just isolate the y and you get your answer, baby. Rock out. Alright. It's not that bad, and I have some beautiful examples for you to try out, and I have some answers on the next page, but look, here's the deal. I won't be doing step-by-step holding your hand. I've got 3 challenges. This one on the top looks very challenging, but you guys need, actually, I did this on purpose. I was thinking proactively, especially in the future videos. You need to get used to properties of logarithms, and I'm sure you guys got this. And I made it so it simplifies out super well. And that's your hint. That's your hint. This one's super straightforward. This one I think is actually kind of hard. I remember having it a pain in the ass. Actually, no, it shouldn't be that bad. You know what? They all should be fine. I remember I made one insanely difficult, and well, let's just say, and they correlate with the shape on the previous slide. Yeah, isn't this one like ridiculous? This one's really funny. Wow. I mean, it shouldn't be that bad actually. Oh no, it's because you have to use integration by parts, but nothing you guys can't handle because I did it, so you guys should be able to do it as well. Anyways, yeah, these two aren't bad. Well, that's it. So I'll see you guys later.